Hello and welcome back for chapter 4. So in chapter 3, we learned about probability and how to write probabilities, how to calculate some probabilities with qualitative data. And now we're going to work on looking at probabilities with quantitative data. And the first type of quantitative data that we're going to work with is chapter 4, and it's over discrete quantitative data. So remember, when we learned in chapter 1 about quantitative and qualitative data can have two types of data, discrete and continuous. So chapter 4 is about discrete quantitative data. So let's go ahead and look at our notes here. So a discrete probability distribution function has two characteristics, and it's very similar to what we learned in chapter 3 about probability. Each probability has to be between 0 and 1 inclusive, meaning it can equal 1 and it can equal 0, but it can be anything in between as well. And the sum of the probabilities is 1. So it has to meet these two criteria. A child psychologist is interested in the number of times a newborn baby's crying wakes its mother after midnight. For a random sample of 50 mothers, the following information was obtained. Let X equal the number of times per week a newborn baby's crying wakes its mother after midnight. For this example, X could be 0, 1, 2, 3, 4, 5, or more times per week, but we only had up to 5 times. So this probability distribution shows the possible outcomes, so 0 times all the way through 5 times. And P of X is the probability of that outcome. So there were 2 mothers that their babies crying woke them after midnight. There was 1 mother where her baby woke her 5 times after midnight. So it says X takes on the values 0, 1, 2, 3, 4, and 5. This is a discrete PDF because each P of X is between 0 and 1, and 2, they add up to be 1, because 2 plus 11 plus 23 plus 9 plus 4 plus 1 equals 50 out of 50 or 1. So this means the sum to add. The pen needs to be replaced to sum. So the sum of my probabilities equals 1. So that's what we have to prove. So let's look at something I'd like you to try on your own. So it says a hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. So I'm going to let you take a minute and read through this and then explain why this is a true discrete probability distribution function. So hopefully you came up with these 2 reasons. One is we noticed that every outcome, every probability is between 0 and 1 inclusive. And 2, the sum of the probabilities equal to 1. 4 plus 8 is 12, plus 16 is 28, plus 14 is 42. Plus 6 is 48, plus 2 is again 50 out of 50, which equals 1. Okay. Let's look at the next example. It says, suppose Nancy has classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days a week, 15% of the time, 1 day, 4% of the time, and no days, 1% of the time. Suppose 1 week is randomly selected. Let X equal the number of days Nancy attends classes, and X takes on what values? Well, they said sometimes she doesn't attend, so that would be 0, 1, 2, and all the way up through 3. Suppose 1 week is randomly chosen. Construct a probability distribution table called a PDF, like the one in our first example, example 1. The table should have 2 columns labeled X, P of X. What does P of X sum to? Okay, so we have 0, 1, 2, and 3. I always start with the smallest and go to the largest. And 0, it says she attends 0 days, 1%. So that would be 0.01. 1 day would be 0.04. 2 days was 0.15. And all 3 days was 0.8. And we're going to make sure that these add to 1. So we're going to have 0.01 plus 0.04 plus 0.15 plus 0.8 gives us 1. So yes. Okay. So they equal 1. It says Jeremiah has basketball practice 2 days a week. 90% of the time he attends both practices. 8% of the time he attends one practice. 2% of the time he does not attend either practice. What is X and what values does it take on? So X is equal to the number of practices he actually attends. Just because there's practice doesn't mean he's attending. And X could be, and then because we're listing values, we always put them in the squiggly brackets. And he could attend no practices, 1 practice, or both practices. Okay, and we could make the table if we wanted to here. We could say X and P of X. The question doesn't ask you to do that, but we could do that just for the practice. And so we could have 0, 1, and 2. And 0 times was 0.02. And 8% of the time he only attends once, and 90% of the time he attends both practices. So that's add up to be 1. Okay. Now that you know how to make a discrete random variable probability distribution function, and to verify that it is true, we're going to go ahead and build our concepts a little bit, and I'll see you for section 4.2.